Okay, here's part 2 of that lesson with 102, 105, 107, 108. Those were all on the previous video, so this one will be 110, 114, 115, 117, and 118. Okay, so in triangle ABC, if I draw a little triangle, I'm not sure what it looks like. We're going to say angle C is 60 degrees, and I know that A is 10, and that B is 14. Now I had to put angle C between A and B because side C is over here. Angle C will always be between those two sides. So use law of cosines to find C. Okay, so I don't know C, so I'm going to say C squared. And then I'm going to do A squared plus B squared minus 2AC times the cosine of angle C, which is 60. All right, all of this can go directly into the calculator, and here's what we get. And we get for C squared 156, and we square root both sides, so the value of C is approximately 12.49 once rounded to the nearest 2 decimal places. All right, next one. Harold, the happy concrete guy, got a call on the phone. Some concrete he has to pour for an odd-shaped triangular patio. The only information he got were the sides are 5, 6, and 8 meters. So find the angles so he can stay happy. So here's a triangle, 5, 6, and 8. And we want to find the angles. So how about we call this angle C and find that one first. Okay, so we're going to find if this is angle C, then this is side C, so we're going to go 8 squared, that's the C squared. It's equal to 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of angle C. So let's calculate each of these. 64 equals 25 plus 36, 25 plus 36, 61 minus 60 cosine C. So let's subtract 61 from both sides, and we get 3 is equal to negative 60 cosine of C. So let's divide both sides by negative 60. And we've got cosine of C is equal to negative 3 over 60, which happens to reduce to 1 over 20, still negative. So we're going to do the inverse cosine of that. So C is going to be the inverse, cosine of negative 1 over 20. And that yields 92.87 degrees. So 92.87 degrees. Now we've got some options here because we have one of our angles. We can use the law of sines to find one of the others because that's actually a little bit faster and I feel easier. So let's now do law of sines and find, say, the measure of angle B right here. So I'm going to say the sine of B is over 6, because those are opposite each other, equals the sine of 92.87 degrees over its opposite side, 8. Now I'm going to do the cross product. So 8 sine B equals 6 times the sine of 92.87. Divide both sides by 8. So sine of B is this value, and then I'm going to need to do the inverse sine of that. So B will be the inverse sine of all of that. So I'm going to calculate that and then find the inverse sine. Okay, so this piece that goes in the parentheses ends up being about 0.749, and the inverse sine of that yields angle B's measure at 48.5 degrees. Once we've got that, it's pretty simple to take a look that all of this is 180. 180 minus this minus that leaves us with our missing angle 38.62 degrees. Now, part B, find the area of the patio that he will be forming. So let me clear some space. Okay, we're going to use the formula where K is equal to half of A times B times the cosine, the sine of angle C. So basically, angle C needs to be an angle between the two sides. So let's go ahead and use the 5, the 6, and angle C. So my area is going to be 1/2 of what I get when I do A5 times B6 times the sine of 92.87 degrees. And this should come up to be approximately 14.98 meters square meters because it's area. All right. 115. Okay, so this is back to another review of how to put these together. So function f plus function g, we just combine like terms, come up with our solution. So there's only 1x squared, and then an x, 2x, and then 1 and a -8 makes -7, and it's as simple and basic as that. B has us doing multiplication, function g, which is 2x, and we need to use parentheses, and function h, 1/2 x plus 1, and we multiply those together. So this is time for FOIL or generic rectangle boxes. How about we do that? So I've got 2x and a -8 and a 1/2 down here, x and a plus 1. So I've got half times 2, so that's 1x squared. This makes -4x. This makes 2x, and this makes -8. So we combine all of our like terms, and we get x squared minus 2x minus 8 for B, right there. Okay, now this is where we substitute one thing into the other. So we're going to substitute all of function h into as the input for function g. So I'm going to rewrite function g right here, but leave some space in place of x, the 1/2 x plus 1, and then continue with function g, or -8. So let's simplify that. Distribute the 2, so we've got x plus 2, and then -8, which leaves us an x minus 6 as a final result for C. And for D, we're going to substitute f of x into itself. So here's f of x, and I'm going to put that x squared plus 1, substitute into x squared plus 1, and that's what we get. So to simplify that, use FOIL and then add 1. So I'm going to leave you to simplify. You please simplify. Next, our last two. Okay, so a nice review of doing some exponents. So rewrite each expression in a simpler form by using the smallest base. So look at all of these. I got 52, 25, and 125. So what's the smallest common base with all of those? You know what? This right here is a typo. This is supposed to be 5 to the second power. So I see in the textbook it does say 5 to the second power. Okay, 25 can be made a base 5 by rewriting. So I'm going to rewrite all of these in base 5. So 5 to the second power, and I'm going to multiply that by 5 to the second power, which is the same as 25, raised to the negative third power, like it says here, and then times 5 to the third. That's where we get our 125 is the same as 5 times 5 times 5. So let's continue simplifying. We've got 5 squared together with our 5 to the third would be 5 to the fifth. And then times a 5 to the 2 times negative 3, so 5 to the negative 6. And then these two leave us with a 5 to the negative 1 power. And there we are. Okay, so using that same strategy, I'd like you to try each of these. Looking at B, I think if you make everything have a base of 3 and simplify, you'll be all set. What would the base be on C? On C, if we, that one's kind of tricky. Let's go ahead and do this one together. You do B. I'm going to do C right here. I'm going to stack these. So all of this above all of this. So I end up with 5 times 14 to the 98th power all over 8 times 14 to the 95th power. And then I'm going to take a look at this piece together and I see 5/8. And that doesn't really simplify, so I'm just going to say 5/8. Now these are going to go together. I'm going to say 5/8 times a common base of 14. And if I'm doing 95 of 98 of them divided by 95 of them, then only 3 will not be simplified. So this is our final result. Okay, so using that same strategy, I'd like you to try D. Because these have negative, they're going to be reversed. So flip those over. All right, now let's take a look at 118 and give that one a try. Recall, the top is the exponent and the bottom is the power. So I'm going to say that this is the cube root of 8. The bottom is the root and raised to the power of 2. The cube root of 8 is 2. 2 squared is 4. All right. And this one, it's going to be the square root of 100, which we know is 10, and then raised to the power of 3. 10 raised to the power of 3 is 1, 2, 3 zeros. And this one, it's the cube root of 125 raised to the power of 2. The cube root of 125 is 5, and 5 squared is 25. And there we have it. Okay, done for the day.